And finally, we've made it to day 3 for lesson 6, intro to functions. All right, so now we are identifying functions. So talk through these problems as a class, then write your answers below. Number 1, arrange. Use a diagram to represent a function. Put these numbers in the ovals to show ordered pairs that form a function. So we have -4, -3, another -3, -1, 1, 2, 5, 5, 6, 7. Complete the diagram that has been started. In the blank diagram, use the same numbers to show a different set of ordered pairs that form a function. All right, so then we already have our 4 and our -3. They use -3 twice already. And then they put this with that. Then we're going to put 1. They already put a 1 and a 2 there, so we'll put 1 with 5. And it goes here. And then we'll have 2 with 6. And 5 with 7. So we use all of our things that we needed. Okay, and we'll do the same thing with a different one. So we'll have -4, -3 can go to -3. Then we could have -3 would then it could go to +2. Then we could have -1 going with 5, 1 going with 6, and 5 going with 7 still. So we didn't switch everything, but we swapped a few of them out. All right, and yours could be a little different, and that's fine. As long as you only had one, like your outputs, the only thing that you had to do is make sure that you had no repeating inputs. No repeating inputs. And then you would have been good. All right, number 12. A bag includes one number card for each of the numbers 1 through 25. Each of 25 students randomly selects a number card from the bag. Carrie says that if the number is the input and the student is the output, the relationship is a function. Mario says that if the student is the input and the number is the output, the relationship is a function. Who's correct and why? So there are 25 different students and 25 different numbers. There is no way for any student to be paired with more than one number, and there is no way for any number to be paired with more than one student. So both relationships are functions, since there are exactly 25 of each. So if you pair them, then they're done. Okay, so since there are exactly 25 students and numbers, there is no way for one student to be paired to multiple numbers or one number to be paired with multiple kids. So both relationships are actually functions. Okay. We'll go ahead and move on to number 13. Analyze. Each molecule of water contains 2 hydrogen atoms and 1 oxygen atom. Complete the table. If the number of hydrogen atoms, is the number of hydrogen atoms a function of the number of oxygen atoms? And explain. So we'd have, again, the oxygen is always half of the hydrogen. So oxygen is half of hydrogen. So this means to get from oxygen to hydrogen, that looks crazy, you just multiply by 2. So 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, and 4 times 2 is 8. So is this a function? So yes, it will be. In each molecule, you could say this. In each molecule, the number of hydrogen atoms is 2 times the number of oxygen atoms. So for any input, there can only be one output. So this means that the number of hydrogen atoms is a function of the number of oxygen atoms. Okay, and we'll go ahead and move on to our final page for this lesson. Number 14, put it together. Sean and Rachel are both born on April 17th. When Sean was 4, his sister Rachel was 2. Write an equation that can be used to determine Rachel's age given Sean's age. Write an equation that can be used to determine Sean's age given Rachel's age. All right, so first we could let S be equal to Sean's age, and of course R be equal to Rachel's age. And what you could say is that you could have these two. Sean's age would be equal to Rachel's age plus 2 years. So we have S is Sean's age, R is Rachel's age, and then Sean's always going to be 2 years older than Rachel. Rachel's age is always going to be equal to Sean's age minus 2, and both of those will be equivalent. Part B, complete the tables of values to show the relationship between their ages. So if we have Sean's age to Rachel's age, if Sean's age is the input, then we're here. So R equals S minus 2, which means that if we have Rachel's age as an input, we'd have S equals R plus 2. So to find Rachel's age given Sean's age, we'll just plug it in and I'll show you how one of them looks. So Rachel's age would equal Sean's age, so we'll start with the first one, minus 2. And so then that means Rachel's age would be 9. And you'll continue on with that. So again, we could just plug in our input, minus 2, 11, and continue on. Sorry, I don't know why I said 11. Because I did, okay, sorry. I went out of my way. This one's supposed to be 11, and this one was 10. And you continue on. Okay? And then if we had Sean, we're trying to find Sean's age given Rachel's age. So Sean's age is going to be equal to Rachel's age plus 2. So we have Rachel's age is 1 plus 2. That means Sean was 3. And if Rachel's 2 plus 2, we'll get Sean's age of 4. And we'll move on, so on and so forth. Okay. Part C, describe the relationships in the tables as either relationship, a function, and explain. So Sean is always going to be 2 years older than Rachel. And Rachel is always 2 years younger than Sean. Okay, so if you use any age for Sean as an input, Rachel will always be 2 less. So there is only one possible output for each input. The same is true using Rachel's age as the input. So is either relationship a function? Yes, both relationships are functions. and it's because of this. All right, and we'll go ahead and move on to part D, which is our last question. The problem states that when Sean was 4, Rachel was 2. Sean's age is twice Rachel's age. Can this also be a rule for the relationship between their ages? Why or why not? No, this cannot be a rule. No, multiplication cannot be a rule to describe a relationship between ages. Okay, it just so happened that I spelled happened extra wrong. It just so happened that Sean was twice as old as Rachel. So literally that was just a coincidence. Age relationships are described using addition or subtraction, and that's all you really need to know here. Only. Okay. And that is all for day 3.